Hi my friends, today we study and we try to model this object, which is a crank. The distance between the two ends, the centers of the two ends, is 625 millimeters. This is why I called it crank 625. The drawing is here, and as you can see, the distance is 625. There are some problems, but I want you to know that the source for this model is another drawing of Timoteo Carrera Soto, an engineer about I told you in the past. See my tutorials 182 and so on. This is our part with some other components here, and this is its drawing, the bottom and the top end. There are some small errors here. As you can see, this is radius 80 and this is also radius 80, but this is corresponding with this arc, not with this one. So we admit that in 1955, when this engineer started with his drawings, it was another mentality, and we have to respect them. There are also some other small mistakes. I converted this to the actual standards, so this is why I made this drawing, which has all it needs. You see, radius 80 is outside here, not here. You can download all the drawings for free by opening Google. Right here, fastgroup.ro, and you open my website, go to diverse, Timoteo Carrera Soto, which is presented in English. You can download each of his brochures, 19, or all of them in one step. Let's use this drawing to create our part. New file, standard millimeters IPT, and we draw a line as a center line from the center down 6 to 5, the length of the crank, as you can see. Then we want to draw this external contour, which is a revolution contour, to create the top end, and we want want to create this other part, end by using the proper dimensions. You see here radius 50, the distance of 3 millimeters, very important between these 2 points. This is the center from where we measure the 625, the bottom, not up, but the external contour is from 3 millimeters up. So let's start. New, millimeters, sketch. We apply center line as a default line, and we draw a vertical line from the center point to the bottom of 6 to 5 millimeters. This is the center line of the part. We start with the half of the profile, going with a line, but not center line, to here, and then I keep pressed the left button of the mouse to go here. Escape, the same vertical between this point and this end, and the same vertical between the center point and the center of the circle. We place here the dimension of 3, as I said, the radius of 50, and then I move a point somewhere here, and I continue with the tool line to draw an arc. This is the construction, and we go somewhere down, and again 2 tangent arcs by keeping pressed the mouse cursor. Dimensions are 50 from this point to this point, 50. This is 6, a radius of 6, diameter of 112, 112, a radius of 26, and also 26. Good. This point must be at 68 from the center point. This dimension is 68. Good. Now I go down to draw the other end, and considering that this is the end of the vertical line of 625, and 115 is the distance between these two. So I start from here, I draw this radius 32, and then I go down with 32 and 80 with the center here at the end of that vertical line. Let's start with the last thing I said, an arc with a center here and the radius of 80. We place this point on this vertical and we draw line arc. This is the line which is converted to an arc. We go to the right, up, arc, up, arc, left, and another arc. Escape. These two lines must be collinear. These segments are equal, these arcs are equal. I suppose this is not tangent. Yes, it was not tangent. And then I place 55, the distance between these 2 points. 55, 115, 15, radius of 32, and also 32 here, and I move this construction, but let me place another dimension here, 10, to keep it stable. And I move this somewhere here, but this arc must be lower, lower, and since this point must be on the same horizontal with the midpoint here, I draw a line, construction line, between this point and this end, and then I make it horizontal, this line to be horizontal. Why? Because the dimension of 625 is from here. Good. Another important dimension is 60 here, and I draw a line between these two ends, not construction. I disable construction, I make this not construction, and I apply tangent between the line and the two arcs. Why? Because I want to place here the dimension of 50. You see? This is roughly the sketch. We need to place other two dimensions. I suppose at least one of them is a tangency, but let's see with auto dimension. Apply. No, they are both dimensions, remove, apply. One is for this point. Oh, I forgot the two dimensions, this diameter and this diameter. This is why. So this diameter is 175 and this diameter is 155, which really is, but I want to place that dimension now is accepted by changing the situation of these points. This point, this point, this is on this line, you see? This is in the air, no problem. But this is on this line, since we see the red line when I select this point. So I click here and I apply delete. Now this point is not on this line. This point is not on this line. So I can convert this informal dimension to a real dimension. How to do this? Anybody knows? Is anybody who knows what to do? If not, I'll show you. I change this setting. You see? This is for driven dimensions and I convert to not driven conversion dimension. And now it is real. Very useful to know. And this is another dimension missing, but we see it here. Tangency. Tangency between these two. And now it is fully constrained. I try to extend the center line, but I receive an error message because of the dimensions. So I need to draw a new center line. I apply center line and I place it here. What happens up? The same thing. Finish sketch. Revolve. Oh, this is missing. Let me draw another short line with the length of 3 millimeters. Center line, line from here to here. Good. Disable this, finish sketch, and revolve. Now we have the volume by selecting the axis, because there are 1, 2, 3, 4 axes here. I have to select the one I want. Okay, the material is steel carbon F6, and we have a starting point. Very interesting, my friends, very interesting. Good. Now I want to apply cuts. As you can see here, there are two cuts. This face is one and this face is another one. The difference between them is 5 millimeters. 70 is here and 65 is here. So I start with 75 for all the part, from up to down, and then I cut the difference of 2.5 millimeters at each side for the other one. So I create a plane, because I cannot use neither this plane, which is placed at the center point, yes, 3 millimeters from this circle down. I cannot use this plane because I have to go up and down. Oh, but this is okay. Yes, let's create a sketch here. All of these are construction lines, and I draw a rectangle which must be tangent to the same circle on all these sides. Yes. Now I can mirror. This is the only freedom line remaining. I can create a mirror of this sketch, but I don't like mirroring sketches. I don't like. So F7 to see inside. I apply the dimension of 70 divided by 2. Divided by 2. Okay, and now we have the profile to apply for cutting all the part from bottom to up. Extrude, the only closed contour is this one. We select this and through all, but cutting. You see, we have here the future. Okay, and then we apply mirror of this last feature, extrusion, about the XY, not XY, but XYZ plane, and we see again the future. Okay, now I want to make this not 70 but 65. This is a problem. I don't want to place dimensions, you see, because when you change some dimension, a cut can be not entirely good. So I make something. I create a plane parallel with that plane and tangent to this sphere. Yes, parallel with the plane of this plane, and I create here a sketch. But I want to see it from the bottom. Now I see from the bottom. I draw a rectangle, but first let me project some geometry here. This arc and this arc, which can be construction lines. Okay. Rectangle. This is the rectangle. It must have this line collinear with one of them, and tangent the two sides with the projected arcs. Now I place dimension from a side to here of 65 divided by 2. Okay, and this is 2.5 millimeters. I use only dimensions in the drawing. I don't write here 2.5 because I can make a mistake. Finish sketch, extrude, cut the other direction, and now I have to place a dimension. Even if I don't want to, I have to place a dimension. I know that this is 115, so 200 is very generous, so I place here 200. If somebody will change the part, I don't suppose that this great difference. If I have doubts, I place 300, no problem, because the 600 here is covering everything. Okay, then I make this not visible. I apply mirror for the last feature about the plane, this plane. Yes. Okay, F6. Now I go to the drawing and I analyze this cut. 60, radius 30, and the distance of 68 millimeters from the center point. This is the center point, not from this point. 68 with radius 30. Let's make this cut. I select a plane, I draw some lines. If you want to know which one is the center point, go to the center point and you see, without any click, you see which one is the center point. I draw some lines, as I said. 1, 2, 3, and I close with an arc. Nothing simpler than this. And now I place the center of this arc in the center point. Oh! I place this point in the center point. Yes, I cannot make a mistake. Now radius 30 and the distance of 68 from this face to the center point. 68. Very good. Finish sketch, extrude. This is to be extruded, but with cut all the way, not a dimension, but all the way. You see the cut. Here is a hole, a big hole of 95 millimeters. Look here, 95. Let's create this. What is your intention? My intention is very simple. I select this, I select a sketch, I go back, and I have a point. This is the center. Hole, not threaded, not other, through the part with a diameter of 95 in this point. This is the point you need to select. If here is a point, a cross point, it is not necessary to be selected. I select it and we have the big hole here, F6. Now I intend to create this hole, two holes, with a diameter of 26, but I see that there are counter bores at both ends. I cannot use the hole tool to create a hole with two counter bores. So I make a revolution profile here. Look at the dimensions, diameter of 44, 54, 26, and ends are on this 115 lines. The distance between the holes is 115, like here. Okay. I use the plane, this plane. I go here, then F7. I draw a line which will be the center line. Then other lines, not important to be exactly. I go here, click and close. Very interesting. Then I place the most important dimension between this and the center point, which is 115 divided by 2. This is 26, but let me make this a center line. Dimension of 26, dimension of 44, and 55 at the bottom. $54, not 55. Good. I try to make collinear this line with this, it works, and this the same. I create a point here, and I project this arc. Why? To place this point on this, on the same horizontal, this point with this point, I suppose this is not horizontal. Let me see. I make collinear these two and it is the same. It was not used, the point. And here I place the point on the arc. Yes, I don't create dimensions as much as I can to avoid placing dimensions arbitrarily. Fully constrained. Finish sketch, revolve. With cut, of course. Okay, what do we have here? We have what we wanted to have. Good. Now is a good moment to create a small cut here. As you can see, in the original drawing, this screw has a nose here, and the nose is placed in a cut of the crank. I have no dimensions for these two. Not here, not in the drawing, I don't have. So I created dimensions for this cut. Radius 15, distance of 6.5 of the center from the center line, and 10 for here. Keep in your mind 10, 6.5 and radius 15. I create this cut. I use the same plane like before, this plane, to create a sketch. F7, home, and we work here. What do we work? We create a circle. You see the radius is selected since I don't have this checked option. If I check it, I draw a circle with a diameter. If I check radius, I can place here the value of 15, because the radius 15, I have not a diameter of 30. Then a dimension of 10 from this circle, well, not necessarily to select the center. I select the circle and this line, 10. Now I need to use the center of this, the center of the hole. So I project this circle and I have the center. I place a point here. It is in the center. The other line has its center somewhere. There is another line here. Maybe this one, I don't know. But this is our center. Escape. I move this to the right and I place the dimension of 6.5 between the point and the center of the circle. 6.5. Okay, now let's see what is the width. we have the width here. I didn't find any other place where to put this dimension. 6. The value is 6, and the cut is here. Good. Finish sketch. Extrude. Symmetrical of 6. And not adding or joining a new feature, but cutting the part with the new feature. OK, F6. Now, if you look to the drawing, you see 2 holes here. 1, 2. Metric 16 placed at the 12 millimeters from the bottom, bottom face, plane face. Okay, to do this I need to have an axis and a point. One of the possibilities to create a hole. Look here, I create an axis, but I don't have a line somewhere to select that line as an axis. So I create a plane starting from here up at minus, you see minus 12, OK, and then I select the plane we already used, this plane, and as you can see, an axis was created. Now I place a point. Without a point I cannot apply the whole tool, and we have this point of start. Hole. The hole is 96, 95. I select the point, I select the axis, I am sure that this is the hole, and now I select a threaded hole and I use isometric profile with a diameter of 16. Now is good, but the hole is not through the part. Yes, let's see how long is that hole. Oh, it goes to the hole here. Good. I go back to the part and I apply 2 and I select this hole. You see, everything is OK. OK. Now I make not visible the point and the axis. I don't want to have ghosts here. Now the hole with its definition, the cut with its definition, and the hole. All of them, all 3 of them, must be mirrored to the other face. I apply mirror, I select the last 3, 1, 2, 3 features. You see they are selected, and a mirror plane, which is our nice XY plane. And you see the future of the part is this. Very good. Now we go up and we see that there are some machinings here. We have to create a small flat face to place a hole with two diameters, 14 and 10, at a distance of 15 from the bottom of this. But first, let's create the faces. There are two faces. Look at the model. You see, this is a face and this is the other one. What is the dimension? The dimension is 110. You see, the diameter here is 112 and the dimension is 110, so this is 1 millimeter between this line and this arc. But we don't consider 1 millimeter. We use 110. You know the system, our system. The system is to use this plane, yes, for a sketch, and F7 to see inside. We have to cut this, not this, but we project this arc and we draw a rectangle. The system, we use our system. Tangency between these two and coincident this end with the line, coincident this end with the line, and now the dimension is 110 divided by 2 for this cut of 1 millimeter. Finish sketch, extrude, cut. We select this because there are also possible other selection. You see here, I didn't make this construction line, so I have to select. And now a large distance as before to create this. 92, no, 200. Okay. The last feature, select mirror plane and select the plane you want. This, and we have a suggestion here. Now I make that hole with 14 here and 10 here at a distance of 15 from this face. To do this, I create a circle. This is the larger and this is the smaller diameter. A point somewhere, but on the same vertical with the center point, and I project this face to have a line, It doesn't matter if these lines and entities are construction or not, because we only use this point. The distance of 15 from the point to the line, 15. Finish sketch, hole. The hole is placed here, and the kind of hole is with counter bore through. The major diameter is 14, the minor diameter is 10, and the point where this is placed is 2. Now, this point, and I select the XY plane, yes, but this is for the end, not for the counter bore, so I don't like it. The hole is through, and this dimension is half of 110. So I write here 110 divided by 2, and you see this is the end of the larger hole. Okay, this is larger, it cuts a little here, and this is the smaller one. F6. The last feature is this M12 with a depth of 12, placed at 65 millimeters from the bottom of the cut. Only on this face, not here. Why to have this? Because as you can see there is something on this end. This is the hole which keeps the screw to not be rotated. Good. To place the hole here, we use the known procedure. We create an axis by creating a plane which is placed at 65 up, and this plane to be intersected with this plane, and we have the hole here. We place a point on this face, on this axis, and we have the start for the hole. Hole is tapped with a diameter not counter bore but cylindrical. The distance is 12. Triple click, 1, 2, 3, 1, 2, 3. This is 12, the depth, and the diameter is ISO of 12 as well, in this point and with this axis. see. Something is not okay. 12 here. The depth. Okay. I make this not visible. I don't want ghosts in my drawings and models. F6, and this is the part, my friends. Let's see what happens with the volume. Is it this part? Properties, physical, update. As you can see, here is a dimension, but it has a range of error of 0.7%. So this is not exactly. We have to see how different is from our creation. This is the new value, which is slightly different from the value there. So I place the new value because I want you to have the procedure I used to create this model. If you use another procedure, you find differences, small differences. One of you, my friends, asked me the other days about this, and my answer was, this is not a fixed or precise value. It is calculated, and it has a range of error. This is the part, and that's all for today. Thanks for watching. Bye bye.